Good morning and welcome to Lesson 3-4 on CPCTC. And what you're probably wondering straight away is, what on earth does CPCTC stand for? Well, CPCTC stands for corresponding parts of congruent triangles are congruent. The whole point of this lesson is we're going to look at ways to use triangle congruence theorems as a stepping stone to prove other things about triangles to be congruent. And CPCTC is the tool we use to do that. In my math lab, they're going to use a slightly different abbreviation. They're going to say CPOCTAC. It still stands for the same thing. It's just more unusual. You're probably not going to see it anywhere else. I just wanted to let you guys know. But I feel like the best way to show you how this works is to just start doing examples. So let's take a look. All right, right here I have two triangles with things marked. I'm given that angle A is congruent to angle E, and that AB is congruent to ED. So let's write that down as our first step. Angle A congruent to angle E, and AB congruent to ED. And looking at this, they've already given me an angle and a side. And my first step is always to prove the two triangles congruent, so I just need to find something else to use to do that. I see I have a vertical angle right here, so I can then say that angle BCA is congruent to angle DCE. That's another angle there for me. And now looking at my pattern, I've got two angles and a side, but the side only touches one of my angles. Oh wait, by the way, these reasons were the vertical angles theorem and given. Sorry guys, I'm doing out of order this morning. All right, so now I can say that triangle BCA is congruent to triangle DCE by AAS, because I've got two angles and a side, but the angle only touches one of the sides. But that's not where I want to stop. I want to stop right here. I want to prove that angle B is congruent to angle D. Well, at this point, I've proven my two triangles to be congruent, which means if the two triangles are congruent, then every piece of the triangle, of one triangle, is congruent to every piece of the other triangle. So I can now say that angle B is congruent to angle D because corresponding parts of congruent triangles are congruent. CPCTC. So CPCTC we use after we've proved two triangles to be congruent, and it's a really handy tool that allows us to say that individual pieces of congruent triangles happen to be congruent. So let's take a look at an example. So here I'm given that GF is congruent to GH, and that FI is congruent to HI. So that will be my very first step, listing out my givens. GF congruent to GH, FI congruent to HI. And I want to prove that two angles are congruent. Well, in order to prove that two angles are congruent, I first have to prove that the triangles themselves are congruent. So that's what I'm going to be looking for. When I look at this diagram, I need a third thing. They've given me so far two sides to be congruent. I'm looking for a third item. I see here they've got a shared side, GI, so I can use the reflexive property to say that GI is congruent to GI by reflexive property of congruence. And because GI is congruent to GI, I can then say that my triangle FGI is congruent to triangle HGI by the side theorem. Now we've proven the two triangles to be congruent, therefore angle FGI is congruent to angle HGI by CPCTC. So it only takes your proof about one step further. Usually it's a really nice theorem. All right, let's take a look at this one. This one has a little bit more work involved for us. Here they tell me that KL is parallel to JM. So KL parallel to JM. And they tell me that KJ is parallel to LM. So when I have this kind of setup, I know I'm going to need to use lots of those parallel line theorems. And my goal is to prove the segment's congruent. Well, to prove the segment's congruent, I'm going to have to prove the triangle's congruent first. So that's my goal. So the first thing I'm going to do, though, is I need to have things to prove. I don't have any angles or any sides right now listed in my proof. So let's take a look. I see right here, I have some alternate interior angles. So I can say angle KJL is congruent to angle MLJ by, oh, it's the converse of the alternate interior angles theorem, guys. Let me write that down. Converse of alternate interior angle theorem. And then I can do a really similar step again and say that those two angles are congruent for the same reason. Angle KLJ is congruent to angle MJL, the converse of the alternate interior angle theorem. And then we can say I have this shared side, JL is congruent to JL by the reflexive property. Well, that's right here, two angles and a side. I look and this side touches both of the angles and both the triangles. So my triangles are congruent. Triangle KJL is congruent to triangle MLJ. They're congruent by angle, side, angle, because the side touches both the angles. Well, now I've proven that the two triangles are congruent. If the two triangles are congruent, then individual pieces are congruent. So I can say that KJ is congruent to LM by CPCTC. Let's take a look at this guy. Here we clearly have some nice overlapping triangles. Let's look and see what we're given. We're given that UW is congruent to VX and XT is congruent to WT. All right, I'm going to give you guys some hints on this one. It will be a lot easier if you redraw it. I also see that they have an angle T right here that's common. So I'm going to redraw these because otherwise this is a really difficult proof to even look at. So right here, this is point U. W's along here somewhere. And then T's down here. And my vertex here is X. And things that are marked as whole sides, this is marked, and those are marked, and I've got T. Now I'm going to redraw the other triangle. It looks a bit like this. Cool. And we have a point here. So this is V, X, T, and point W. And things we have marked, we have those marked, that marked, and we have a shared angle. So this one's going to take a little bit more work because if you look, we've got some very, very clear segment addition postulate happening in here because I've got two pieces, not a whole piece. So it's going to take me a little bit more time. But that's okay. I'm going to start off by listing my givens. UW is congruent to VX, and XT is congruent to WT, which is given. And so I'm now going to go ahead and take care of that overlapping T. I'm going to say that angle T is congruent to angle T by the reflexive property. Okay, now let's go back to our diagram here. I've proven this angle, and the side that's already proven that I don't have to do any work with, the fact that WT is congruent to XT, that's really helpful. What's not as helpful is what's happening here, right? Here I'm going to have to basically prove that because those two congruent pieces are put together, therefore the segments are equal. So I'm going to have a little bit of work ahead of me, but that's okay. So I'm going to start off by using the segment addition postulate to say that VT equals VX plus XT. Do the same thing with the other one. UT equals UW plus WT. Both of those are segment with a T addition postulates. Okay. Then I'm going to make some clever substitutions, but I can't make any clever substitutions until I have things equal to each other. So this step right here, I'm going to alter it down here and say UW equals VX and XT equals W. That should be a capital. What am I doing, guys? WT by the definition of congruent. Okay. Then I'm going to make some clever substitutions. And I'm just going to choose one of these two statements up here to make clever substitutions with. I think I'm going to do it right here with UT. So I'm going to look at UT. And here, rather than writing UW, I can instead write VX. So I'm going to say UT equals VX plus. And instead of writing WT, this allows me to write XT. So VX plus XT. Now, why do I like that? I like that because if you look here, I had this in terms of Vx plus xt, and now here is Vx plus xt. So I'm going to be able to use transitive property. Substitution POE. So let's do that. Let's use some transitive property. I can now say that UT equals VT by the transitive property of equality, which is excellent. And if two things are equal, they are also congruent. UT is congruent to VT by definition of congruent. Well, guys, that gets me my third side right there. Yeah? That's my third side. So at this point, I can now prove my two triangles to be congruent, right? Because this now is my third side here. I'm going to prove them by SAS. So UXT is congruent to triangle, well, let me look at them again. Triangle WVT by SAS. And therefore I can now finish my proof to say that triangle angle UXT is congruent to angle VWT by CPCTC. Yay! Alright guys, I want y'all to do this one on your own. This is your try me. Try it. Come to class. Do not skip it. Do not skip it. Okay? Alright guys, y'all have a great day, and I will see you all in class. Thank you.